Hello everyone, good evening. Hello everyone, good evening. अभी तक कोई नहीं आया है. So let's wait for some minutes, then we'll start the session. So let's start today's session. So in these sessions we are going to discuss about the typical gate questions on Fourier series. So the first question is from gate 1998. Here you can see that a periodic signal xt of period t0 is given by this equation. xt is given by this equation xt. So xt का value क्या है? The value of xt is equals to 1 when mod of t is less than t1, and it will be value of 0 when the mod of t is greater than t1 and less than capital T0 by 2. So what will be the DC component of this xt signal? So from this example you can see that we can find the DC value in two ways. So if we first draw this xt, so let us first draw the xt. So if we draw the xt, so we are going for the method 1. So if we go for the method 1, so we can find the DC value using two methods. So we are going for the first one, that is the method 1. So in the method 1, what we can do, we can first draw the xt signal. So this is the graph of xt. So you can see the graph xt where the y-axis is the xt and this is the time axis. So now what is given t1, so let us put t1 here. So suppose this is capital T1 and suppose this one is capital T2, capital T1. So this is minus T1, this is minus T plus T1. So now if I look at the xt, the graph will look like this. The graph will be within T1 to minus t1, the graph will have a amplitude of 1. So this will have an amplitude of 1, and after t1 it will have amplitude of 0, and after t1 minus t1 there will be amplitude of 0. So that means this amplitude is 1. Now from this graph, so this is a periodic signal, it is given. So this is a periodic signal. So if it is a periodic signal, then we can find the value of xdc. So xdc value क्या होगा? The value of xdc will be 1 by the time period, divided by 1 by time period integration of xt dt, or lower limit will be minus t by capital 2 to plus t by capital 2. But in the question it is given that the time period is capital T0. So we will put the value. So if we put the value, so xdc will be 1 by capital T0 integration minus T0 by 2, 2 plus T0 by 2, and xt dt. So now if I want to find the value of this integration, then you can see that within minus t to plus t, the value is 1. So if I put the limit, so 1 by t0 जैसा है वैसा ही रह जाएंगे, because this is the time period, and integration minus t to plus t, so xt dt. So minus t1 to plus t1, minus t1 to plus t1, the value of the signal from the figure you can see that it is 1. So यहाँ पे 1 हो जाएंगे xt की जगह पे, so dt. So if you do this integration, what you will find after doing the integration, you can see it will be 1 by t0, or after integration it will be t1 minus of minus t1. So that means it will be 2 of t1, so 2 of t1 by t0. So this will be the value of the DC component. So this is how we can find the value of the DC component. Similarly, we can in the method 2, in the method 2 we can find the value of the DC component. So xdc by just by the average value, that is the area under the curve, divided by the time period, divided by the time period. So area क्या है? So area is this duration into this height. So that means 2t1. So यहाँ पे होंगे आपका 2t1 into 1 divided by, that will be t0. Okay, time period is t0, so 2t1 by t0. So from the both method we are finding the same value, that is 2t1 by t0, यहाँ पे भी 2t1 by t0. So this is how we can calculate the value of the DC component of xt. Okay, so now we will go for the next question. The next question is from GATE 2000. So you can see the question. So question क्या है? Question is given by one period of 0 to t. One period of 0 to t, that is given here. So one period of 0 to t, each of two periodic signal waveform W1 and W2 are shown in the figure. The magnitude of the nth Fourier series coefficient of W1 and W2 for n greater than equals to 1, n odd are respectively proportional to this thing. So you have to find this question. So now if you look at the question, so let us find the question. Now in this question you can see that one period of 0 to t, that means this is one period first of all. this is one period. Similarly, there is another period of the other signal. So this is another one period of the W2 signal. Now we have to find that the magnitudes of the nth Fourier series coefficient. So what do we need to find? The magnitude of nth Fourier series coefficient. Nth Fourier series coefficient for n greater than equals to 1, and this n value will be odd होना चाहिए. So that means n का value क्या हो सकता है? If n greater than equals to 1 and n is odd, so n will be 1, n will be 3, n will be 5, n will be 7, like this. So now what we need to do? The magnitude of the nth coefficient. So we have to find the magnitude of the nth coefficient for these two graphs in the Fourier series. And we also know that the most important thing that, so the first graph W1, the first graph W1 is a rectangular graph. Rectangular graph. And the second graph W2 will be a triangular graph. It is a triangular graph, you can see from the graph. Now according to the Fourier series, hopefully you remember, I have discussed this in the class, that the Fourier coefficient Cn of a rectangular graph is proportional to 1 by n square. What is n? N is the order. Similarly, for the triangular graph, we know that this is not n square, this will be n. Reciprocal to, it will be inversely proportional to n, and in the case of triangular graph, it will be inversely proportional to 1 by n square. So now, if we want to find the nth Fourier coefficient for, so nth Fourier coefficient will be Cn, and Cn will be proportional to 1 by n. So for greater than 1, greater than equals to 1, so if it is greater than equals to 1, then what we can say? The magnitudes of the nth Fourier coefficient of W1 and W2 for n greater than equals to 1 and n is odd are respectively proportional to. So that means किसके साथ proportional होंगे? So rectangular graph के लिए, मतलब W1 graph के लिए, it will be proportional to, Cn will be proportional to n to the power minus 1. So it will be proportional to n to the power minus 1. So hopefully you can see that n to the power minus 1. Okay. And here Cn will be proportional to n to the power minus 2. So that means what will be the answer? Answer will be this one. So Cn will be proportional to n to the power minus 1 and Cn will be proportional to n to the power minus 2. So option C is the right answer. So this is how we can find it. इसका derivation भी है. We will not go for the derivation. So this is a trick of finding the rectangular coefficient Fourier series and triangular graph Fourier series. Okay. So now we'll go for the next question. The next question is from GATE 2015, and this question is very, very important. So we'll discuss this question right now. So the magnitude and the phase response. So magnitude and the phase response is given. So we are going for that. So you can see that what is given here. It is given that the magnitude and the phase of an complex Fourier series coefficient AK of a periodic signal xt are shown in the figure. So this is the magnitude plot and this one is the phase plot that is given. So we have a signal xt, and the signal is periodic. It is given in the question, periodic, and we have done the exponential Fourier series. So if we done the exponential Fourier series, then what we can see, we will get a magnitude plot. We will get a magnitude plot and we will also get a phase plot. So in the magnitude plot, we must get xk mod versus k value, and in the phase plot we will get the angle of the AK versus the k value, and that is two graph is given here. Now choose the correct statement from the four choices given. Notation: C is the set of complex number, R is the set of purely real numbers. So there are different sets. One is C set, that is the complex number set. R is the real numbers, purely real number set, and P is purely imaginary number set. So now we have to say that xt belongs to R, xt belongs to P, xt belongs to C minus R. The information given is not sufficient to draw any conclusions about xt. So first of all, if you look at this graph of angle graph, so you can see that the angle of AK has different value. So angle of AK, either it is 0 or minus 180 degree. So it is 0 or minus 180 degree. We can see this from the graph. ये वाले graph से मैं देख सकता हूँ. Another thing, what we can see from the Fourier series coefficient, we can also write. So if you remember the exponential Fourier series, then you can see that AK can be written as magnitude of AK e to the power j angle of AK. In this way I can write. So what you can see, AK can be written as plus minus of AK, because the angle is either 0 degree or minus 180 degree. So we can write plus AK or minus AK. If it is 0 degree phase angle, then it will be plus of AK. If it is minus 180 degree phase angle, so it will be AK will be minus of AK. So you can see that this AK value is purely real value. So it is purely real value. So if it is in this AK value, there is no J term, so it is purely real value. So if AK is purely real, so what we can see that the exponential Fourier series coefficient, so exponential Fourier series coefficient AK is purely real. So purely real value. So if the coefficient is purely real value, so when the coefficient is purely real value, if and only xt, that is the periodic signal, मतलब ये जो AK है, ये AK xt का periodic AK का xt is the exponential Fourier series coefficient of xt, and AK is purely real. So xt must be purely real and symmetric. So that means which option will be correct? So option A is the correct. It will be purely real, so xt must be inside the real set. So that's why the option A will be the correct answer. Now we'll go for the next question. this question. It is also from the GATE 2015, and this question is also very important. In this question, what you can see? In this question, consider a discrete time periodic signal. So it is a question of DTFS. So it is a question of DTFS, and the DTFS means there will be a discrete periodic signal, and the discrete periodic signal is given by sine pi n divided by 5. Let AK be the complex Fourier series coefficient of xn. So this has a Fourier series coefficient. Fourier series coefficient has AK value. The coefficient AK are non-zero. So it has been told that the AK value are non-zero. So this AK value are non-zero. And K value is given as Bm plus minus 1. So when the K value is Bm plus minus 1, where this m is any integer, m is any integer, then the AK will be non-zero coefficient. So if AK is non-zero coefficient, then the value of B we have to find. We have to find the value of B. So now from this discrete time signal, what we can see? We can find the frequency, fundamental frequency. What will be the fundamental frequency? That will be omega 0, and omega 0 को मैं लिख सकता हूँ 2 pi by capital N. So that means it will be pi by 5. From this you know how to find the value of fundamental frequency of a discrete time signal. So you can see that the N value is capital 10. So N is capital 10. So the period of the signal is 10. Now Xn can be represented as, so if I represent Xn, so Xn value can be represented as sine pi n. So it will be 2 pi n divided by 10. I can write this. Okay. So now from this question, I can, if I convert this sign into the exponential term, so it will be 1 by 2j multiplication e to the power j into 2 pi n by 10, 2 pi n by 10 minus e to the power minus j 2 pi n by 10. Okay, so now you can see that we have found an exponential equation. Now if I represent the Xn into Fourier series, if I want to represent the Xn in Fourier series, so what will be the Fourier series? So it will be k equals to 0 to capital N minus 1 ak e to the power j 2 pi k divided by n. Now just put the values of capital N. So if I put the values of capital N, then it will be k equals to 0, and here 10 minus 1 is 9, and this will be ak, and it will be e to the power j 2 pi k divided by 10. Okay, so now if I put the values of different k, so first value will be a0, so e to the power j 2 pi 0 divided by 10 plus a1 e to the power j 2 pi 1 divided by 10. In this process I can find the different terms, and up to a9 e to the power j 2 pi 9 divided by 10. Now if I compare these two equations, if I compare this equation number 1 and equation number 2, so if I compare these two equations, I can find the values of A1. So यहाँ पे देखिए कि 2 pi n by 10 है, so 2 pi n by 10. Okay, so यहाँ पे, so there here it will be e to the power j 2 pi kn, यहाँ पे n होना चाहिए, so there will be must be a n here, so यहाँ पे भी n होगा, so this is n, so which term is present? 2 pi, this term is present, and 2 pi n by 10, so this term is present. Okay, so now if I compare this, so what we can see that the values will be of A1, the values of A1, it will be 1 by j2, okay, and the values of A minus 1, it will be minus of 1 by j2. So these are the two values of A1 and A of minus 1. So if these are the two values of this thing, so what we can see that the A0 value, so AK value is equals to AK plus n value. So that means A0 value will be equals to A of 10 value. So since the Fourier series periodic with time period same as the small signal, so that means A1 will have the same value as 11 and A of minus 1 will have the same value of 9. So that means the K value, which is given by Bm plus 1, so what we can see that we have non-zero coefficient A minus 1, A1 and A9, A11, A9, A21. So that means if we put B equals to 10, so B value will be 10 because यहाँ पे B value 10 है. So if B value is 10 and if we put M equals to different integer value, that is 0, 1, 2, 3, like these values, so the value of the B must be 10. Okay, then we can get the values. So if B is 10, so 10 plus 1, that is 11. Okay, so 0, 10, 11. In this way we can find the values of B. So this is how we can find the values of B. Okay, so now we will go for the next question, that is the question of 2015 set 3. 2015 set 3. So 2015 set 3. So now let us see the question. So in this question this is a very important question. Just read the question first. So here you can see that it is given that let x cap n is equals to 1 plus cos pi n by 8. So the given signal is also a discrete time signal, and the signal is 1 plus cos pi n by 8. So it is a periodic signal given with period equals to 16. So n is equals to 16. Okay, so if n is equals to 16, so it is its DFS coefficient, matlab discrete Fourier series coefficient, is defined by, so it is given by AK is equals to 1 by 16 summation n equals to 0 to 15 xn cap exponential minus j into pi by 8 kn for all values of k. Then find the coefficient A31. So we have to find the value of A31. Okay. So now for discrete Fourier series, we know that the coefficient ak must be ak plus n. So that means A31 can be written as a, the period is 16, so that means A16 plus 15. So that means it will be equals to A15. And A15 can also be written as A16 minus 1, so that is equals to A minus 1. So now if we want to ये वाले इक्वेशन को अगर मैं एक्सपोनेंशियल फॉर्मेट पे लिखता हूँ, सो व्हाट आई कैन राइट, सो x cap n that is equals to 1 plus and this is cos theta. So cos theta can be written in the exponential form using the Euler's theorem. So that means it will be half into e to the power j theta value is pi n by 8, so pi n divided by 8 plus e to the power minus j theta, that is pi n by 8. So that means if I write this equation in this format, so half e to the power j pi n by 8 plus half e to the power minus j pi n by 8. So now if I compare, you can see that a minus 1 value, what is the value of a minus 1? So a minus 1 value is half and a0 value is 1 and a1 value is half. So what we can say that A31, so A31 is nothing but a of minus 1 and half. So in this way we can find that the coefficient of A31 is half. Okay. Now let us move for the next question. So this is the question and it is of 2016. So you can see the question. So here it is written, a signal 2 cos 2 pi by 3 into t. So what is the signal given? So let us write the signal. Suppose the signal is xt is equals to 2 cos 2 pi by 3 into t minus cos pi t is the input to the LTI system with transfer function this. Matlab this signal has been given input to a LTI system which has a transfer function hs. Hs is given by this equation e to the power s, what is this? E to the power s plus e to the power minus s. This is the transfer function. So if Ck denotes the kth coefficient of the exponential Fourier series of the output, so suppose there is an output and this output has the kth exponential Fourier series coefficient, EFS coefficient is, what is the value? That is the Ck. Then the C3 is equals to what? Simple as that. So now the transfer function Hs is given by e to the power s plus e to the power minus s. So I can put s equals to j omega. So e to the power j omega e to the power minus j omega. In this way I can write. So if I write this, then the xt signal, so from the xt signal you can see that xt signal, it is given by 2 cos 2 pi by 3 into t minus cos pi t. Now I can write this x1t plus x2t, where x1t is equals to this thing, this part, and x2t is this thing. Now if I write that, so what is the x1t? x1t is equals to this thing. So x1t is equals to 2 cos 2 pi by 3. So if I write x1t equals to 2 cos 2 pi by 3 into t, and this will have a fundamental frequency omega 0 is equals to 2 pi by 3. Okay, so now if I want to find the value of h e to the power j omega 0, what is omega 0? Omega 0 is this thing, 2 pi by 3. So now it will be 2 cos, let the put the value. So if I put the value, so it will be 2 pi by 3 into t. Okay, 2 pi by 3. So this will be this thing. So now you will get the value. So it will be 2 into minus half, that is minus 1. Okay, now this one will be the value. Now what will be the y1? So y1 value मतलब x1 के लिए आपका, this is an LTI system, so it will follow the LTI behavior. So if xt can be written as x1 plus x2, so y will also be y1 plus y2, and x1 will be the input for which the output will be y1, and y2 will be the output of x2. So that means the output for x1t will be y1t. So y1t will be minus 2 cos 2 pi by 3 into t. Similarly, if we go for the x2, so x2 is given by cos pi t, cos pi t. So cos pi t, here the fundamental frequency is pi. If the fundamental frequency is pi, so what will be the value of the transfer function e to the power j omega 0 at omega 0 equals to pi? So the value will be cos, the value will be e to the power j omega here, and we can find the value. So the value will be 2 cos pi, that means minus 2. So now y2t, what is y2t? y2t value will be minus 2 cos pi t, this thing. So yt will be equals to y1t minus y2t, this will be the value. So now yt is equals to minus 2 cos 2 pi by 3 into t plus 2 cos pi by t. So from this we can find the value of main signal. So yt is this thing. So if yt is this thing, so yt क्या था? Yt was, if I write the yt, it was minus 2 cos 2 pi by 3 into t plus 2 cos pi t, 2 cos pi t. Now from this you can see that omega 1 value is 2 pi by 3, omega 2 value is pi, and here t1 is equals to 3 and t2 will be equals to 2. So t0 will be LCM of T1 and T2. So that means it will be 2 and 3 LCM, so which will be 6. So omega 0 will be pi by 3. So if omega 0 is pi by 3, so yt can be written as minus 2 cos 2 omega 0 t plus 2 cos 3 omega 0 t. Okay, so this is how we can find. So now if I put the Euler's theorem here, cos theta e to the power j theta plus e to the power minus j theta divided by 2, then we can find e to the power j 2 omega 0 t minus e to the power minus j 2 omega 0 t plus e to the power j 3 omega 0 t plus e to the power minus j 3 omega 0 t. So this is how. So if I want to find the C3 coefficient, so what will be the C3 coefficient? So there is the C3 coefficient. Okay, so the C3 coefficient will be 1. Okay, so here C3 coefficient value is 1. So this is how we can find the value of C3 coefficient. Now let us go for the next question. So let us find the next question. So if I go for the next question, so this is the next question, GATE 2018. So GATE 2018, let us see the question. This is a very important question. So now we'll go for the next question, that is GATE 2018. So here you can see that it is written that let xt be a periodic function. So if xt be a periodic function with time period t equals to 10, so that means they have given that xt is a periodic function. So it is a periodic function and the time period is given by 10. The Fourier series coefficient of this series are denoted by xk. So this has a Fourier series coefficient, and you can see this thing, this is an exponential Fourier series, so EFS, and the EFS Fourier series coefficient is given by AK. Okay, so this is the AK Fourier series given. AK is the coefficient of the EFS. So now here xt is given by in the exponential Fourier series. So the exponential Fourier series, it is given that k is equals to minus infinite to plus infinite, and this is xk e to the power j into k 2 pi by capital T into t. It is given. The same function xt can also be considered as a periodic function with time period t equals to 40. So आपको मैंने क्लास में बोला था आपको कि आपके पास अगर कोई xt होता है और वो xt अगर 10 सेकेंड से पीरियडिक है, सो उसको मैं 40 सेकेंड से पीरियडिक भी बोल सकता हूँ, 40 सेकेंड से पीरियडिक भी बोल सकता हूँ. ओके, सो उसी चीज यहाँ पे बोला गया है कि t equals to 40. Let bk be the Fourier series coefficient then when the period is taken as t dash. So if this mod k is 16, so mod bk is equals to what? Simple as that. So now when the time period we are taking as 10, then the coefficient is ak, and it is given that summation of ak for k equals to minus infinite to plus infinite is 16. So we have to find the bk. Now we know that there is no change in the Fourier series coefficient on applying time scaling property. So what we have done, आपके पास एक, suppose we have a xt like this. Suppose we are having a xt like this. So suppose this is 0 to 10. So this is 20, this is 30 and this is 40. So इसका जो फंडामेंटल पीरियड है वो तो 10 है. जब मैं 10 फंडामेंटल पीरियड ले रहा हूं तो मेरा एक एक का समेशन ये हो रहा है. नाउ इसी चीज को मैं क्या कर सकता हूं, इसको मैं बोल सकता हूं कि इसका जो पीरियड है वो इतना सा पीरियड है, यहां से लेकर यहां तक. ये भी मैं बोल सकता हूं जिस 40 पीरियड. सो व्हाट वी हैव डन, वी हैव डन द टाइम स्केलिंग ऑपरेशन. एक्चुअली वी हैव डन द टाइम स्केलिंग ऑपरेशन. पहली बार मैं बोल रहा था कि द टाइम पीरियड इज 10, नेक्स्ट मैं बोल रहा हूँ 40. दोनों सेम सिग्नल ही है. मैं इसका टाइम पीरियड 20 भी बोल सकता हूँ, इसका टाइम पीरियड 30 भी बोल सकता हूँ. सो व्हाट वी आर डूइंग द टाइम स्केलिंग, एंड वी नो दैट द टाइम स्केलिंग प्रॉपर्टी of a signal on the Fourier series. So what we know, sir, we know that in the Fourier series coefficient, if we apply the time scaling property on the signal, then the Fourier series coefficient will have no change. Will have no change. So that means if we have xt and if we have the Fourier series coefficient as Cn, then if we do the time scaling property, that is x of at, then the Fourier series coefficient will also be Cn. There will be no effect. So that's why the summation of k equals to minus infinite to plus infinite of ak will be same as the k equals to minus infinite to plus infinite of bk. दोनों सेम होंगे, that is equals to 16. Okay, so this is how we can find the values. Now we will go for the next question. So this is another question of electrical. In the electrical branch, this question has came. So you can see the question. The question looks like this. The question is very simple, but the statement are the statement is very complex. What is written here in the question? They have given a GT signal, and GT signal equals to T minus this bracket. This bracket is different. You can see what this bracket means. Largest integer less than or equals to T. ये कब होगा? जब मेरा T greater than equals to 0, and T minus this bracket into of T. Otherwise, what this bracket means? This bracket means smallest integer greater than or equals to T. A given equation. So the coefficient of the second harmonic. What will be the coefficient of the second harmonic of the Fourier series? So say coefficient of the second harmonic of the Fourier series. So now the waveform of T, and so let us first find the waveform of T. So if I want to find the waveform of T, so how it will look like? So this is the graph. Okay. Now suppose this is T, टाइम एक्सिस के साथ मैं T प्लॉट कर रहा हूँ. सो ग्राफ कैसे आएंगे? ग्राफ आपको लीनियर ग्राफ मिलेंगे बिकॉज T के साथ T प्लॉट कर रहे हो आप. ओके. नाउ इफ आई प्लॉट मॉड T, सो लेट अस प्लॉट मॉड T नहीं, सो T ब्रैकेट. So we are plotting this graph, that is T and T bracket. So what does it mean? So in the right hand side we will get the largest integer Okay, and in the left hand side we'll get the smallest integer. Okay, so that means if we have a value here, so largest integer value will be here. Similarly, there will be here and here. Similarly, we can say that if the value is here, the smallest integer will be there. If the value is here, the smallest integer will be here. So the waveform of GT, how can we find? So the waveform of GT, if I draw the waveform of GT, so let us draw the waveform of GT. So this graph, time axis, and here the GT. Okay, so now this is T, this is GT. So कोई भी ग्राफ ले लीजिए. So T minus this thing, so that means the graph will look like this. The graph will look like this. Like this. और बीच में आपको ऐसे मिलेंगे. यहाँ पे आपका लीनियर प्लॉट होगा. लीनियर प्लॉट like this. So this is the graph, you can see. So this is plus 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. Okay, and the magnitude is minus 1 here and plus 1. This will be the graph look like. So now, since the waveform is non-periodic and the Fourier series expansion, it is a non-periodic signal. So the Fourier series expansion is only valid for the periodic signal. So the second harmonic component of the Fourier series must be 0, because there is no Fourier series, because it is a non-periodic signal. So that's why the answer will be 0. Okay, so this is how we can find. Now let us go for another question of electrical branch. Electrical branch का और एक question देखते हैं. Okay, so let us find the question. So the question looks like this. So suppose we have a signal xt. So this will be the last question. So summation k equals to minus infinite to plus infinite, and minus 1 k into del t minus k by 2000, and this signal is passed through an LTI system. So this signal is passed. ये कौन सा क्वेश्चन है? आपका 2017 का क्वेश्चन है. 2017 का क्वेश्चन. So this signal is passed through an system, and this is an LTI system. ये कौन सा system? आपका LTI system. Okay. So the LTI system has the frequency response h omega given by this a graph. So this is h omega, and the graph looks like this. This is omega, and the graph looks like this. So this is 5000 pi, and this is minus 5000 pi. This is 0, and this is 1. So the Fourier series representation of the output signal. We have to find the Fourier series representation of the output signal. This is how we have to find. So now if we look at the question, then xt is given, okay, and the system response is given. So if I draw this xt, so what will be the representation? So for that purpose, let us draw the xt. Okay, so now we are drawing the xt. So if we draw the xt, then suppose this is 0. So this is 0. Okay, so in this x-axis, what will be this? This is the time axis. Okay, this will be the time axis. Now where we can find the samples? So ये आपका एक impulse है. So this is an impulse function. So if we put the values of k, then I can find the different samples. So we'll get at t equals to 0 पे आपको एक sample मिलेंगे. Okay, t equals to 0 पे एक sample. So again at 1/200 पे 1/2000 पे एक sample मिलेगा. Okay, then we'll get 2/2000 पे, so 2/2000 पे, then 3/2000 पे. If you put different values of k, then 4/2000 पे. Similarly, you will get -1/2000 पे. Then this one. So what will be the values? The values will be, this is 0, this is 1/2000 पे, this is 2/2000 पे, this is 3/2000 पे, this will be 4/2000 पे. Amplitude क्या होंगे? +1, +1, +1, this will be -1, -1, -1. The value of the time is 1/2000 and this is -2/2000. Okay, -2/2000, amplitude +1. So this is the xt actual. If you put different values of k, we will get this. Okay, so what is the time period of this? So we can see that the time period will be equals to 1/1000. So what will be omega 0? Omega is equal to 2π/t. So that means 2000 pi. Now the Fourier series expansion. You have to put the Fourier series expansion. You know the omega 0. Okay, you know the omega 0, and you put the Fourier series expansion. So if you put the Fourier series expansion, ultimately formula क्या है? xt is equals to a0 plus summation n is equals to 1 to infinite an cos n omega 0 t cos n omega 0 t plus summation n equals to 1 to infinite bn sin n omega 0 t. Okay, so a0, if you find the value of a0, the value will be 0. If you find the value of bn, it will be 0. You can only find the value of an, that is equals to 2/t integration capital T, and it will be xt cos n omega 0 t into dt. Just put the values and find how to find. You know how to find these values. So if you find the values, you can see that the an value will be equals to 4/t for n is equals to 1, 3, 5, 7 dot dot and 0 otherwise, and 0 otherwise. So this will be the an value. Just put the values n here. This bn is 0, this a0 is 0, so it will, you will have only this one. So you will have the Fourier series as, it will look like this. The Fourier series of the output will be, so xt का जो Fourier series होंगे, it will be look like this कि 4/t cos 2000 pi t, next plus 4/t cos 6000 pi t, प्लीज इसके बाद डॉट डॉट होंगे. Now you can see that this LTI system is passing 5000 pi से लेकर minus 5000 pi तक. So which of the signal will come to the output? So output पे आपको मिल जाएंगे this thing. This thing will be come out the output only. They will be blocked. This thing will be blocked. Okay. So this is how we can find the value of the Fourier series of the output. Okay. Any doubt, anyone? कोई doubt है किसी को? Any doubt? Is it clear? This was the last question जो मुझे लगा है कि Fourier series में आपको प्रॉब्लम हो सकता है. इतने सारे क्वेश्चंस हम लोग यहाँ पे डिस्कशंस किए. अगर कोई क्वेश्चंस पे डाउट हो तो मुझे बोलिए. एनी डाउट, एनीवन? ओके. सो ये था आपका फूरियर सीरीज का 10 इयर्स का क्वेश्चंस. जो मुझे लगा है कि ये क्वेश्चंस आपका डाउट हो सकता है, वो सारे क्वेश्चंस हम लोग यहाँ पे सॉल्यूशंस किए. सो इन द नेक्स्ट सेशंस वी विल डिस्कस अबाउट द प्रीवियस ईयर क्वेश्चन ऑफ फूरियर ट्रांसफॉर्म्स. ओके. सो थैंक यू एवरीवन. गुड नाइट. आई एम एंडिंग द सेशंस हियर. सो थैंक यू.